Welcome back to another fascinating journey through the wonders of our universe. Today, we're diving deep into the intriguing realm where physics, chemistry, and the very essence of life itself converge. But before we embark on this exploration, let me pose a question to you. Have you ever wondered how the laws of physics and chemistry, the fundamental forces that govern our universe, can possibly account for the extraordinary events within a living organism? It's a question that has captivated the minds of scientists for generations. So, without further ado, let's delve into the timeless query originally posed by the pioneering physicist Erwin Schrödinger. What is life? Guiding us on this intellectual journey is none other than the distinguished physicist Brian Cox.
There's a very famous book called What is Life by Erwin Schrödinger, father of quantum mechanics. It's based on some lectures he gave in Dublin in 1943. And the thesis of the book, he asks it right on page 1, it's how do the laws of physics and chemistry account for the events in space and time inside a living organism, he says, which essentially is saying, how can the laws of physics and chemistry explain life? And he goes on to address two things, really. One is he essentially predicted the existence of DNA. He calls it an aperiodic crystal, so a molecule that can carry information from generation to generation. But also he looks at the thermodynamics of life. And this, to me, was even more interesting. It's the challenge to physics to say, given the second law of thermodynamics, which says that the universe tends to disorder. So we know this, that this is the way things are. If you leave things, they get more disordered. How is it that these ordered structures form? The human brain being the most ordered structure we know of in the universe. How did that form spontaneously from a collapsing cloud of dust 4.8 billion years ago or so? And so those questions I get asked a lot. So from my previous series, Wonders of the Universe, we dealt with entropy in terms of the heat death of the universe and everything falling to bits. And it's natural for people to say, well, what about life? Life runs counter to that. So when Schrödinger speaks to that, and now we understand quite well, it's called non-equilibrium thermodynamics. So it's basically the idea that a physicist can attack these questions, profound questions, from the point of view of a physicist. For example, the order, the entry point for order in the biosphere is essentially photosynthesis. So essentially what's happening is that you're getting ordered energy from the sun, and disordered energy as heat is being re-radiated back into space. And there's almost an order gap. Life essentially borrows some order for a while. And so we filmed in a lake in Palau, which is full of jellyfish who have photosynthetic algae inside them. And so that they actually essentially are an animal that lives as close as you can to photosynthesis. So the symbiotic algae take the light from the sun and they use that as food for the jellyfish. So you can tell the story of how photosynthesis essentially begins to build order by CO2 and water and make sugar. Well, that's an ordered molecule from two less ordered things because you've got this ordered light from the sun.
In conclusion, as Professor Brian Cox has brilliantly illuminated, life on Earth is intricately connected to the ordered energy we receive from our sun. Through the miraculous process of photosynthesis, nature transforms this energy into the building blocks of life, generating order from the seemingly chaotic universe. It's a captivating reminder of the exquisite balance that sustains our planet and fuels the grand tapestry of life. Thank you for joining us on this captivating journey into the mysteries of existence, and stay tuned for more fascinating explorations of our wondrous universe.